Hello everyone. Today we're going to be talking about inverse of a function. So first, for some notation, the inverse of a function f is notated as f to the negative first power. And we just read that as the inverse of f. The graph of a function's reflection across the line y equals x is a function's inverse. So for example, if I had the function f of x is equal to 2x plus 3, the inverse of x would be equal to x minus 3 over 2. So here we see this blue line is my f of x. This red line is the inverse of x. And I see that this red line is reflected across the line y is equal to x. So if I were to fold this graph here, I would see that these would end up matching up because it's reflected across that line. And something you'll notice when we make a table of values for f and the inverse of f, I see we have the same values, they're just flip-flopped. So for f of x, I have x is negative 2 to 2, f is negative 1, 1, 3, 5, and 7. But then when we go to the inverse of f, we see that my f of x terms become my x terms, and my x becomes my inverse of f. So they swap places, and we'll see that every time with these inverses. And so for this video, we're going to be looking at finding the inverse of a linear function, and there's going to be 4 basic steps that we're going to do. First, we're going to rewrite the function as an equation with x and y. Second, we're going to switch x and y. Then we're going to solve the equation for y and replace y with the inverse f of x. F inverse of x, another way you can say that. So let's look at some examples. I want to find the inverse of each of these functions. So I have f of x is equal to 3x minus 1. My first step is to rewrite the function as an equation with x and y. So to do that, I'm going to replace my f of x with y. And then my second step is to switch my x and y. So then this becomes x is equal to 3y minus 1. And now I'm going to solve this equation for y. So I have this 3 with y and this minus 1. I want to first move my minus 1 over. So I get x plus 1 is equal to 3y. And then I'm going to divide everything by 3. So I get x plus 1 over 3 is equal to y. And then my last step is to replace y with f inverse of x. So this becomes that my f inverse of x is equal to x plus 1 over 3. So now if I wanted to check this, I could go ahead and graph both of these. So if I were to graph this f of x equals 3x minus 1 and f inverse of x is equal to x plus 1 over 3, I would see that they would reflect across the line y is equal to x. Let's look at another one. So here I have f of x is equal to negative x plus 1. My first step is to replace f of x with y. So I get y is equal to negative x plus 1. Now I need to switch my x and y, have those switch places. And so when I do that, I get that x now is equal to negative y plus 1. And now I need to solve this equation for y. So I want to subtract 1 from both sides. And I get x minus 1 is equal to negative y. And then divide everything by negative 1. And so when I do that, I get negative x plus 1 is equal to y. And now my last step is to replace y again with f inverse of x. So I get that f inverse of x is equal to negative x plus 1. Okay, let's look at one more. So this third one, I have f of x is equal to 1/3 x minus 2. My first step, I need to replace that f of x with y. So I get y is equal to 1/3 x minus 2. And now I'm going to have x and y switch places. And so this becomes x is equal to 1/3 y minus 2. Add 2 to the other side because I want to now solve for y. So I want to get y by itself. And so I get x plus 2 is equal to 1/3 y. And now to get rid of that 1/3, I just need to multiply both sides by 3. And so when I do that, I need to make sure I distribute this 3. So I get 3x plus 6 is equal to y. And the last step is to replace that y with f inverse of x. So I get f inverse of x is equal to 3x plus 6.